Hello and welcome to the Science of Sleep, where your pillow becomes a spacecraft, and your thoughts float through realms even Einstein had trouble wrapping his head around. Here, in this quiet space, there's nothing you need to solve. No formulas, no answers. Tonight, you don't even need to remember what a photon is. All you have to do is rest. Let me tell you a bedtime story about the universe. One that's not about monsters or fairy tale dragons, but something even stranger, reality itself. You see, when you zoom in far enough beneath the molecules, beneath the atoms, and even beneath the protons, you begin to find a world that refuses to behave. Imagine this. You're walking through a misty forest, where trees sometimes appear behind you after you've passed them. The leaves glow faintly, until you look at them, then suddenly, they're just normal leaves. In this forest, the rules bend to your gaze. That's quantum physics. And we're just getting started. So, stretch out. Let gravity pull you softly down. You won't fall space, has you? Let's begin with a curious thought. What if everything solid around you, your bed, your blanket, your very fingers, is not really solid at all? Atoms, the building blocks of matter, are mostly empty space. The nucleus is like a fly in a football stadium, and the electrons, well, they're not exactly particles in the way you'd expect. They're more like suggestions, possibilities, floating maybes. And yet this bizarre fog of probabilities somehow gives rise to the thud of your head on a pillow, the warmth of your body under the covers, and the texture of the fabric brushing your arm. How does this work? Let's talk particles. You've probably heard of electrons, tiny charged specks that orbit the nucleus of an atom. At least, that's the comforting high school version. In truth, electrons are not little marbles. They are waves of probability. They don't exist in a specific place until you look. The moment you observe them, they decide where to be. It's called the wave-particle duality. And yes, it's as if nature can't choose between being a wave or a dot. So it does both, until it absolutely must commit. And this isn't just some woo-woo idea. It's been demonstrated again and again, especially in the famous double-slit experiment, which we'll get to later. But for now, just know this. Before you observe it, an electron doesn't have a location, it has a probability cloud. It exists in many potential states at once. When you measure it, the cloud collapses, and the electron chooses a position. It's like a magical game of hide and seek, except the particle is hiding in every place until you peek. So you might be wondering, does that mean reality is made up of guesses, of shadows that only solidify under our gaze? Yes, kind of. But don't panic, your tea mug is still a tea mug. It's just that underneath that mug is a chaos of particles playing peekaboo. Take comfort in this. The laws of quantum physics are incredibly precise. Weird, yes, but shockingly reliable. In fact, we use quantum mechanics to build lasers, GPS systems, and the phone that's probably sitting on your nightstand right now. Without quantum theory, your playlist wouldn't work. So even if reality is fuzzy and odd at the microscopic level, it's that very weirdness that powers your everyday life. Here's a curious fact to rest your head on. Every atom in your body is about 99.99999999999999996% empty space. That's 13 nines. If atoms were scaled up to the size of apples, you would be the size of a cathedral, filled with mostly air. And yet you don't fall through the floor. Why? Because forces, not solid stuff, create the sensation of solidity. Electromagnetic forces between particles repel each other just enough to keep you standing, sitting, or curled up with a pillow. It's like being held up by invisible cushions that never deflate. Now, imagine you're a particle, lounging in a void, not quite committed to being anywhere. You're more possibility than thing, a ghost of yourself, a maybe. Then, along comes a giant flashlight observation, and poof, you exist, but only then. This isn't metaphor. It's the actual conclusion of centuries of quantum experiments. The universe doesn't fully decide what it is until it's being watched. Isn't that slightly unnerving? Or maybe it's comforting. Maybe your presence matters more than you think. It raises unsettling questions. Is the moon still there when no one looks at it? Einstein hated that idea. He once asked, Do you really believe the moon isn't there if you're not looking? To which quantum mechanics gently shrugs and replies, well, maybe. Now this doesn't mean the moon vanishes when you sleep. It means the quantum level behaviors, the fundamental rules that underlie atoms, don't follow classical logic. Classical logic is like chess. Quantum logic is like trying to play chess while the pieces occasionally become musical notes or clouds. And yet, out of this unpredictable game emerges something breathtakingly stable. You, the bed, your breathing, the dreams you will soon sink into, they're all the miraculous consequence of a universe that works, even when it doesn't make sense. So tonight, let your thoughts settle like particles unobserved. Let them hover, uncertain and free. There's no need to force an answer. Just imagine a world where everything is real, and also maybe not yet. Let's stay in that strange place between sleep and sense, where questions hum and answers hover just out of reach. You're still lying there, warm and weightless, drifting through the invisible fabric of reality, but something else is floating nearby, something even smaller than an atom. It's a particle. Or it isn't. You've met the electron. Tonight, let's visit its cousin, the particle that wasn't there. Here's a sleepy little miracle. In the quantum world, particles can exist and not exist in the same place at the same time. Let's say you're playing a game of hide and seek with a subatomic particle. You open the closet, nothing. Under the bed, nothing. You turn around, and suddenly it's sitting on your pillow, smug and unbothered. But here's the twist. It wasn't really hiding. It wasn't really anywhere. It was a probability spread across the entire room, and the moment you looked, it became. This is called superposition, and it means a particle can exist in multiple states at once until it's observed. Yes, like being both awake and asleep, which ironically is probably how you feel right now. One of the clearest examples of this strange behavior is something known as the quantum eraser experiment, a variation of the classic double-slit experiment. Don't worry, we'll get to the OG version in a bit, but for now, imagine firing one particle at a wall through two narrow slits. Over time, you expect to see two lines appear on the back wall, one for each slit. Simple enough, right? Except that's not what happens. Instead, you get an interference pattern, like ripples from two stones tossed into a pond, a wavy barcode. But here's the kicker. This happens even when you fire the particles one at a time. Each particle behaves as if it went through both slits and interfered with itself. It's as if the particle becomes a ghost of itself and plays patty cake across both paths simultaneously, until you decide to look. The moment you add a detector to figure out which slit it went through, the interference vanishes. No ripples, no wave, just two boring lines. The particle picks a side and refuses to play anymore. You didn't touch it. You didn't change the slits. All you did was try to know, and that knowledge collapsed the ambiguity. This isn't just spooky, it's strangely intimate. The act of observation seems to sculpt reality out of raw possibility. Here's where it gets weirder. In the quantum eraser version, you can detect which path the particle took after it hits the wall, and depending on whether that info is available, the pattern changes. It's as if the past rewrites itself based on what you choose to know in the future. Sleepy yet? You should be. Your brain is working overtime, trying to reconcile a world that doesn't want to be boxed into categories like here or there. Let's soften the language. Think of reality not as a thing, but a blur, a smudge of maybes, like a soft watercolor bleeding at the edges. The more closely you look, the more it changes, retreating into vagueness, then crystallizing when you finally dare to stare. In the quantum realm, certainty is a party crasher. The moment you invite it in, all the fun superposition, ambiguity, mystery evaporates. Here's a fun little truth bomb to dream on. Every particle in your body is doing this, constantly. Electrons in your brain, protons in your bones. The entire fabric of your being is built from pieces that don't always agree on whether they're there or not. Still think you're made of solid stuff? Now, don't worry. You're not going to vanish because someone walked out of the room. Superposition tends to collapse quickly when you're part of a large, noisy system like, say, a warm-blooded human curled up with a podcast. but somewhere deep in your cells, a few quiet particles might still be playing both sides. Want another odd fact? Some particles don't even need to exist for very long. They flicker into being, hang out for a fraction of a moment, less than a trillionth of a second, and then vanish without a trace. Just long enough to maybe affect something else. Physicists call them virtual particles, which is just a fancy way of saying they weren't quite real, but they showed up anyway. These ghosts are constantly bubbling up from the vacuum of space. They may never leave evidence behind, but they change the math. They change the rules. They change you. And still, this isn't magic. It's measurable, predictable. The math of quantum physics is so precise, it's been tested to over 10 decimal places. If reality is a messy smudge, it's an exquisitely choreographed smudge. Of course, not everyone agrees on what this means. Scientists still debate whether particles really exist in multiple states, or if the math is just a tool we use because we don't have the whole picture. Some say the universe splits into many versions, each representing a different outcome. Others say the act of observation is an illusion, and there's a hidden variable we just haven't found yet. And then there's you, floating in this gentle uncertainty, where nothing is solid, and yet everything holds you. So what do you do with this information? Well, you don't have to do anything. You're not being tested. No exams here. But maybe, just maybe, the next time you feel unsure about a decision or direction, remember the electron. Remember how it lives in possibility, not paralysis. It waits not passively, but potentially, and then, when seen, it becomes. You are more like that than you think. There's comfort in knowing that uncertainty is not a flaw. It's baked into the universe. And it's okay to hover in maybes, to be a little here, a little there, to change your mind, to drift. Now, settle back. Let the thought fade like mist. And somewhere, a particle that wasn't there just smiled. Still here? Good. You're floating through this field of strangeness now past the not-quite particles and maybe waves. Your thoughts are beginning to unravel in the best possible way. You don't need to grip them anymore. Just let them dissolve, like sugar in warm tea. And speaking of things that can't make up their mind, let's talk about light. The kind that falls softly through your bedroom window in the morning. The kind your bedside lamp scatters across your walls. The kind your eyes depend on to navigate the world even if they're closed now. What is light? A wave? A particle? Both? Neither? Physicists have been asking this question for centuries, and Light Cheeky as ever refuses to commit. It's like that friend who RSVP'd maybe and shows up dressed as two different people. We now know that light is a quantum object. It behaves like a wave when we're not watching, and like a particle when we are. This isn't metaphor. This is how the universe works. It's called wave-particle duality, and it's not just a quirk, it's a law. Imagine you're at a beach. You see gentle waves rolling toward the shore. That's the wave version of light. It spreads, interferes, diffracts, creates rainbows in soap bubbles, and makes CD reflections shimmer like tiny galaxies. But now, imagine those waves aren't continuous. They arrive in tiny packets like water balloons hurled by an invisible toddler. That's the particle version. Each one is called a photon, a single unit of light. Here's the thing. Whether light acts like a wave or a photon depends entirely on how you measure it. Shine it through slits? It makes an interference pattern. Set up a detector to catch individual photons? Suddenly, it's acting like discrete bullets. It's the ultimate choose-your-own-adventure story, and the ending changes based on your curiosity. And yes, this has been tested, repeatedly, in labs filled with lasers and scientists pulling their hair out, wondering how something can be both smooth and grainy, both spread out and localized, both predictable and absolutely not. So, what's going on? Some physicists propose that it's all about information. When you could know the path light took when the possibility of knowing exists, it behaves like a particle. When that information is unavailable, it reverts to a wave. Not because it prefers ambiguity, but because it must follow the logic of uncertainty. Think of it this way. Reality doesn't just wait to be observed. It waits to be decided upon. And sometimes, it seems to change its story retroactively. Let's tiptoe back to the quantum eraser for a moment. In some versions of this experiment, you can choose after the photon hits the screen whether you'll preserve or erase the which path information, and the interference pattern appears or disappears accordingly, which implies, incredibly, that the light's past behavior depends on a future decision. It's as if reality isn't a line, but a soft, quantum sponge, absorbent, adaptable, unbothered by time's usual marching orders. Sleepy enough yet? Let's keep going. Remember how photons are particles of light? Well, they don't have mass. They travel at the speed of light naturally, and because of that, time doesn't pass for them, literally. A photon born in the sun's core and absorbed by your eye traveled across 93 million miles in 0 time from its point of view. Think about that for a second. Or don't. It's bedtime. Here's an odd little thought. If you were a photon, you'd experience your entire journey instantly. No waiting, no delay, just go, and you're there. Poof. You could technically say that from the photon's perspective, its birth and its death are the same event, which is poetic and slightly terrifying. So light doesn't just illuminate your world, it compresses it. It's a messenger from the edge of space, carrying whispers from stars so far away. Their messages began before the Earth had trees. But somehow, it also knows when you're watching. Creepy? Maybe. Or maybe comforting, because the universe seems to pay attention, even when you're just blinking behind closed eyes. Now, back to Earth. You've got light bouncing all around you. From your phone screen, shh, put it down. From the moon, from the glowing numbers on your alarm clock. Each photon is telling a story. Each one carries energy, momentum, and the gentle hint that everything is connected by invisible waves. Some of those waves sound like my voice, cozy in your ears right now. Others are electromagnetic like radio, Wi-Fi, and gamma rays, which we kindly keep at bay. All of it, this sea of waves, is described by one elegant set of equations called Maxwell's equations. They unified electricity, magnetism, and light into one beautiful family. But here's what Maxwell didn't know. His equations described waves, not particles. It took quantum theory to add the twist, that waves can also be single things and that things can behave like waves. This is the identity crisis at the heart of modern physics, and we are built on top of it. Let's come back now. You, lying there, wrapped in softness, eyes closing. Every moment you spend wondering about light is a moment you're also being light. Your cells emit it. Your brain responds to it. Your skin absorbs it. You are illuminated from within. Light isn't just something you see. It's something you are. And tonight, whether you understand it or not, whether you measure it or just let it wave, it's okay. Some things don't need to make sense to be beautiful. Let the photons dance at the edge of your thoughts. Let them shimmer into sleep. Let's not wake up yet. You're still drifting, somewhere between the softness of memory foam and the edge of reason. You can feel it, can't you? That gentle hum beneath the silence, like the universe breathing underneath your sheets. Now, it's time we visit one of the strangest, most whispered to about experiments in all of science. The one that makes physicists squint at reality like it's lying to them. It's called the double slit experiment, and it's quantum physics' most elegant prank. Don't worry, this won't hurt your brain much. Just let it wash over you, like waves that may or may not exist. Here's how it goes. You take a flat screen, and in front of it, a wall with 2 slits, tiny openings side by side. Then, you shoot particles at the wall. Not metaphorical particles, real ones. Electrons, the stuff that makes up atoms. You send them one by one. Now, common sense says, each electron will go through one slit or the other, right? You'd expect 2 clumps to appear behind the slits, like footprints in sand. But instead, you get interference. Not 2 blobs, but a banded pattern, light and dark stripes, like ripples overlapping in a pond, a wave pattern. But wait, electrons are particles, aren't they? You didn't fire a wave. You fired individual particles. And yet, The pattern suggests each one somehow passed through both slits and interfered with itself. It's like sending marbles through two mail slots and getting fingerprints from a ghost. So, you get clever. You add detectors to see which slit the electrons go through. And guess what happens? The interference vanishes. Now you get two boring blobs, no more ripples, no more mystery. It's as if the electrons knew they were being watched and thought, all right, I'll behave. They go from wave to particle just because you're peeking. Weird, right? But it gets weirder, because if you turn the detectors off again, the pattern comes back, like the electrons are sighing in relief. Phew, back to being weird. And it's not just electrons. Photons do it too, even entire atoms. It's as if all matter has this secret double life behaving like a wave unless someone tries to pin it down. It's not that we don't know where they are. It's that they aren't anywhere in particular until measured. Let that lull you into stillness. Right now, in this very moment, particles are traveling through your body, your blanket, the air itself, and they don't decide what they are until they're asked. Until the universe says, hey, what do you want to be? And like a shy actor on a quantum stage, they pick a role and stick with it. At least until the curtain falls. Here's a curious thing. Some versions of the double-slit experiment have tried sending one particle at a time over minutes, hours, even days. No waves interacting with each other, just solo particles. And yet, over time, the same interference pattern appears, as if each particle remembers the ones that came before, or as if it's interfering with itself across time. Of course, scientists argue about what this really means. Some say the particle exists in a superposition, taking all paths at once. Others propose the universe splits one version for each possible outcome. This is where the metaphysical meets the measurable, where physics becomes poetry, and where you, lying still in bed, become a kind of detector too, because every time you think, you collapse something. Every observation you make, no matter how mundane your ceiling, your breath, the little hum in your ear is shaping a version of reality that could have been many things until it became this. So what does that say about you? Are you a participant? A co-creator? Or just an accidental observer? Maybe all three. Let's pause for a moment and let the darkness settle. Feel the fabric on your skin, the air on your cheek. That's your body in the classical world, definite, solid, warm, but underneath that comforter of matter is a frothing uncertainty. And that uncertainty is not a bug. It's the code. It's how reality keeps its options open. You see, classical physics, the kind Newton taught us, describes the world beautifully. Gravity, momentum, apple, falling on head type stuff. But it doesn't explain this. It doesn't explain why a single particle can act like a probability soup. Quantum mechanics does. And yet, even it can't tell us why. We have the math. We have the experiments. But we don't have the story. We have effects repeatable, predictable, spooky, but not the cause. Which leads us to this bedtime whisper. Science doesn't explain everything. It explains what happens. It doesn't always explain why. And that's okay. Because mystery is not the enemy of knowledge. It's the breath between questions. Let's drift here a little longer. Imagine the double-slit experiment as a gentle metaphor. You, standing before two choices, two paths, and until you step forward, you exist in both possibilities. You haven't chosen, you're still choosing, and only when you move does your story collapse into a single outcome. That sounds human, doesn't it? Like those mornings when you haven't decided who you'll be yet, or those evenings like now when everything's suspended in maybe. So let it stay suspended. Let the slits remain unmeasured. Let your thoughts ripple. Tomorrow will observe itself. Tonight, be the wave. You're floating now, somewhere between your breath and the space beneath it, where dreams don't quite form and thoughts no longer finish themselves. The world feels soft, like cotton pressed gently against the edges of your mind. Stay there. And while you're here somewhere, neither here nor there, let's talk about something that might change how you see everything. The observer effect. You've already met it briefly like a ghost in the hallway of that strange quantum house. But now we're opening the door. Because here's the unsettling, wonderful truth. In the quantum world, you can't just watch. Observing a particle changes it. Even measuring it changes the outcome. This isn't poetic license. This is the cold, tested reality of quantum physics. The moment you try to know something, it alters itself. And it's not just about light or electrons anymore. It's about you, the observer, the listener, the one curled under a blanket, letting words trickle in like a breeze through half-open windows. You're not on the outside of reality. You're in it, intertwined, entangled. The act of observing makes you part of the experiment, which makes reality feel oddly personal. Let's rewind. In classical physics, the world is passive. You look at a clock, and it keeps ticking. You throw a ball, and it arcs through the air whether or not you're paying attention. You could watch or not, the universe doesn't care. But in quantum mechanics, the very act of looking seems to matter. It's not that your eyeballs are magic, though, let's be honest, they are kind of amazing. It's that measuring, in any sense, changes things. The moment a system is disturbed by observation, by light, by detectors, by interaction, it collapses into a specific state. No more maybes. Just one real, measurable something. So what happens when the observer is human? Now, we have to be careful. People love to leap from observation matters to consciousness creates reality. That's debatable. Some interpretations of quantum physics, like the Copenhagen interpretation, suggest the act of measurement. Any measurement is what forces a particle to pick a state. Others go further, flirting with the idea that consciousness itself might be the final observer. That reality becomes real only when we witness it. Is that true? Well, scientists still debate whether consciousness plays any role in quantum collapse. Most physicists lean toward no. They argue that measurement is a physical process, not a spiritual one. That you don't need a brain, just an interaction. A click on a detector, a photon bouncing off an object. But that hasn't stopped people from wondering. And why not? It's deliciously mysterious. It raises the question, how much of reality happens when no one's watching? Imagine a tree in a quantum forest. It doesn't fall or not fall. It hovers in a limbo of possible sounds and maybe tumbles until anything observes it. Not even a person, just a squirrel, or a dust particle, or time. And then, poof, it picks a path. So you're not just lying there in bed. You're participating. Every observation you've made, from the freckles on your arm to the outline of the curtain in the moonlight, has helped shape this very moment. You collapse 1,000 probabilities just by being here. Maybe that's why being present feels so powerful. Because, on some level deep beneath molecules and neurons, you're not just living inside a world. You're building it. Observation isn't just passive. It's creative. Of course, there's a flip side. This means there's a part of the universe that will always resist certainty. No matter how closely you look, no matter how many decimals you chase, some things will remain unknowable, unreachable. Not because they're hiding, but because they are changed by your looking. That might sound frustrating, but isn't there something beautiful about that? Something soft, like trying to hold fog in your hands, only to have it kiss your palms and disappear. Here's a fun little oddity to drift on. Electrons don't spin in place like planets. Instead, they exist in a kind of smeared-out whirl, a probability distribution. They only appear to have definite spins or positions when you measure them. And depending how you measure them, the result will change. It's like trying to capture a dancer mid-motion, only to realize the pose depends on where you placed your camera. Even at the smallest scales, the universe is interpretive. It reacts. It responds. Which means maybe we should stop thinking of science as a window into a fixed reality, and instead think of it as a conversation. One where every question nudges the answer into form. One where you're not just receiving information, you're shaping it. You, in your silence, in your stillness, in your sleep, you're part of the whisper that tells matter what to be. Let that carry you deeper. Let it make you feel, oddly, more real. Not because you know more, but because you matter. And tomorrow, when you open your eyes and see sunlight through the slats of the blinds, or watch steam rise from a cup, or catch your own reflection in a foggy mirror, remember, those photons are just now collapsing into meaning. And they waited for you. Stay where you are, don't move too far from the warmth pooling around you, or the hush that's gathering in the corners of the room. You're still drifting, still softly afloat in that space where thoughts have edges but no weight. Let them come, let them fade, like the tide pulling gently at your feet. Tonight, we'll follow something elusive, something that exists not just in the air around you, but inside you, beneath every cell, every molecule, every soft breath you don't notice. It's called superposition, and it's a word that sounds complicated but feels strangely familiar, because you've lived with it your whole life without realizing. Superposition means that something can be in more than one state at once. It's not metaphor, it's not just indecision or a poetic shrug, it's physics. At the quantum level, particles don't choose a lane, they blur. They exist in multiple realities simultaneously, not because they're confused, but because that's simply how things are before they're observed. They're not here or there, they're here and there, until you look. Now imagine you are that particle. You're not awake or asleep, not happy or sad, not one thing or another, but many things, overlapping, potential, and when someone reaches for you, or calls your name, or softly opens the door and whispers your presence into focus, that's when you become, that's when you choose. It's strange, isn't it? This idea that the universe itself holds back from certainty, that even something as basic as position or velocity can exist in a cloud of maybes. It's as if the world is dreaming itself. And every time you observe a detail, every time you reach out with your mind, it wakes up just enough to be that version, that moment, that choice. Superposition is why an electron doesn't orbit like a planet, but instead floats as a cloud of possibility, hovering in a probabilistic fog until something forces it to declare itself. And even then, it doesn't tell you where it's been, only where it is now, as if its past was just a collection of blurred pages that never settled into print. Scientists discovered this through countless experiments. Send a particle through a system, and if you don't observe it, it behaves like a wave spread out, full of interference and rhythm. But the moment you peak, it collapses. It becomes a thing in a place. It picks a side, like a child caught between games. It sounds absurd, but it's measurable. It's not just theory, it's the basis of quantum mechanics. Without superposition, there would be no quantum computers, no MRI machines, no understanding of atomic behavior. It's built into the world so deeply that your own brain may rely on quantum coherence for certain tasks, like navigation, memory, or even consciousness itself. And yet, it remains hidden from view, quiet and reluctant, as if it prefers to remain unknown. Here's something quietly wonderful. Photosynthesis, the process plants use to turn light into life, may depend on superposition. When a photon of light strikes a plant, it excites an electron into a quantum state that explores multiple paths simultaneously to find the most efficient route for energy conversion. Not metaphorically, literally. The energy chooses the best path, because it tries all of them at once. It's not just the cosmos, it's your garden, your spinach, the moss growing along a riverbank that doesn't know your name, but breathes because superposition is real. And if that's true, if living things depend on quantum possibility, then maybe uncertainty isn't something to fear. Maybe it's something to rest in, like the pause before a kiss, like the hush before a note, like the soft darkness before a star is born. There's an old thought experiment, maybe you've heard of it, called Schrodinger's cat. A cat is placed in a box with a quantum device that has a 50% chance of releasing poison, according to quantum rules. Until you open the box, the cat is both alive and dead. Not metaphorically, mathematically. In superposition, two outcomes, one reality waiting to be chosen. It's meant to highlight the absurdity of applying quantum logic to large objects. But it also asks, when does possibility end and reality begin? When does the wave function collapse? When is the cat alive, and when does it die? And what if at some level you, too, awaiting in a box of maybes, always on the edge of becoming. Now, scientists still debate whether superposition is a real physical state or just a mathematical tool for prediction. Some say the particle is never really in both states, it just seems that way. Others say it truly exists in multiple places, and it's our measurement that reduces it to one. But no one denies that the effects are real. No one argues with the numbers. The equations work, and the results change the world. So what does that mean for you? It means you're never only one thing. You are layered, shifting, full of hidden states. You're the past and the potential, the smile you gave someone 3 years ago and the breath you haven't taken yet. You are soft probability, folded into flesh and memory. So, tonight, let yourself be in superposition. Be tired and curious, calm and wondering. Be both close and far, here and drifting. Don't try to collapse the moment into a neat thought. Let it stay open, like a gate in a dream. You are not just a thing in a place. You are a field of possibilities, gently held by silence. And as you fall deeper, you don't need to decide who you are. Not yet. Let that truth shimmer just outside your reach, like starlight through water. And now, with your body growing heavier, your thoughts growing lighter, let's move deeper still, past particles that blur, past waves that remember, past the quiet hum of uncertainty, and into something truly magical, something that Einstein himself called spooky. And he wasn't joking. It's called quantum entanglement. And it's not just science. It's intimacy written into the code of the universe. Here's how it goes. Take two particles, let's say, electrons. You link them in a particular way. Maybe they were born together, like twins, or they bumped into each other in a quantum dance. Whatever the reason, they become entangled, which means their properties are no longer independent. You can separate them by a room, a continent, a galaxy, and still, what happens to one instantly affects the other. Even if they're light years apart. Even if you measure one here, and the other is floating somewhere near Alpha Centauri, your action now changes the result there, instantly. No signal, no delay, no traveling at the speed of light. Just connection. It sounds like telepathy, like something out of a sci-fi bedtime story. But it's real, it's measurable, and it's been confirmed again and again in countless experiments. You might wonder how this could be possible. Surely one particle can't know what the other is doing. They're not sending messages. They're not peeking over each other's shoulders, but they are connected not in space, but in state. Entangled. One reality split across two places. And here's the twist. Until you measure one of them, neither has a definite value. They're both floating in that superposed maybe cloud you now know so well. But the moment you check one, boom, it's like the universe snaps into a shared agreement. The other one now must have a complementary value, even if it's trillions of miles away. Einstein hated this. He called it spooky action at a distance. He believed there had to be some hidden variable, some secret message passing between the particles behind the scenes. But as it turns out, no such message exists. In 1964, physicist John Bell designed a theorem, an elegant piece of logic that let scientists test whether quantum entanglement could be explained by hidden information. The experiments that followed first in the 1982nd and continuing to this day proved the quantum view correct. Particles really are connected in ways that defy classical understanding. The universe doesn't run on separate clocks. It runs on shared rhythm. So what does that mean for you? Well, it means you are never fully alone. Not in a sentimental way. In a physical, fundamental, stitched into the fabric of reality kind of way. The atoms in your body were born in stars. They've touched light, been part of molecules, bonded with others. The quantum fields they emerge from are everywhere, humming the same silent music, pulsing with shared information. Maybe, just maybe, there are parts of you entangled with moments far from here. Maybe the laughter you gave someone years ago still echoes in a spin state, waiting to complete its match. Maybe love, in some strange way, is more than metaphor. You see, entanglement isn't just a physics curiosity. It's the basis of quantum computing. where qubits can be entangled to perform massive calculations in parallel. It's being explored for quantum communication, two encryptions so secure, no one can eavesdrop without disturbing the message. And beyond the tech, it's a whisper that everything might be connected in a way we don't yet understand. Physicists still debate what this means. Some think it's just math, a correlation with no deeper cause. Others believe it points to something more holistic, a reality that is not a patchwork of things, but a single vast system shimmering with unseen links. You don't need to decide which view is right. That's not your job tonight. Your job is to breathe, to float in this soft idea, to let the world feel less fractured. Imagine this: two particles, born together, sent out in opposite directions, and yet still dancing the same silent step, still speaking the same language. Now, imagine yourself entangled not with particles, but with people, with choices, with moments. Maybe you don't always know the effect you have on others. Maybe someone you smiled at on a train 3 years ago still carries that spin, that flicker of light. Maybe your thoughts ripple further than you'll ever know. There's something comforting about that, isn't there? The idea that connection isn't limited by time or space, that some threads hold, no matter how far they stretch. So tonight, as you curl deeper into the blanket, let that thought sink in. You're not isolated. You're entangled with memory, with possibility, with people who think of you when you're not around, with moments you haven't met yet. And just like those particles, maybe you don't have to do anything special. Maybe just being here still, quiet, open is enough to keep the dance going. Let the night stretch between you and the stars. Let the connections remain unseen, but strong. Let the strangeness be a kind of peace. Because sometimes the universe doesn't explain itself. It just holds you. You're still wrapped in it, aren't you? The warmth, the quiet, the feeling that something bigger is unfolding just beyond your reach. And that's exactly where we need to be, because now we're stepping into a place where even time begins to unravel. Not in the dramatic science fiction way. No exploding clocks. No wormholes spinning you into the arms of your childhood self. No paradoxes involving grandfathers and broken timelines. Just the soft, unsettling truth that on the quantum scale, time doesn't always behave the way you expect. You've lived your life in one direction. One moment becomes the next. The past becomes memory. The future remains unknown. Time flows like a river, and you float on it with your thoughts, your stories, your breath. But in the quantum world, the river doesn't always flow. Sometimes it loops. Sometimes it splits. And sometimes it runs backward. Here's a strange little tale to fall asleep to. There are quantum experiments where the outcome of a measurement appears to influence what happened before the measurement was made. This isn't magic, it's data. In certain delayed choice experiments, variations of the double slit setup, you already know a photon's behavior changes depending on a choice made after it has passed through the slits. It's as if the particle waits until the last possible moment to decide what it was doing all along. So the question becomes, was the past real? Or was it updated? This doesn't mean you'll wake up yesterday or that cause and effect are meaningless. At your scale, at human scale, time is sturdy, reliable. But beneath that reliability is a delicate quantum thread, one that seems to shimmer with potential even in the rearview mirror. There's a concept called retrocausality, a theory that suggests future events might influence the past at the quantum level. It doesn't mean fate is real, or that your cereal this morning was caused by your decision to watch a science video tonight. It just means the universe might be more relational than directional. That cause and effect might sometimes be a handshake instead of a push, a shared agreement between moments, softly folded. So here's a question to hold as your breath begins to slow. What if time is not a straight line but a field? Not something you travel through, but something you exist within a landscape of possibilities. And maybe your conscious experience of now is just a thread weaving through that field, creating a narrative you can follow. It's not just speculation. There's evidence. In quantum equations, time doesn't always appear as a flowing variable. Some formulations treat it more like space, just another dimension. Some theories, like the block universe, suggest that all of time exists at once, past, present, and future, like pages of a book already printed. You're simply reading one sentence at a time. And yet, there's motion, there's change, there's growth. So where does that come from? Some physicists argue that time emerges from entanglement, that the arrow of time is a byproduct of quantum correlations spreading out. Others suggest that entropy, the tendency of systems to move from order to disorder, is what gives time its flow. And entropy, if you remember, is deeply tied to heat, memory, and even sleep. So perhaps what you're feeling now, that slow drift, that gentle unraveling, isn't just fatigue. Maybe it's your body moving with time's deeper rhythm, not the one on clocks, but the one stitched into reality. Here's something beautifully odd. At the smallest scales, particles don't have clear pasts or futures. A particle's path from point A to point B isn't one straight line. It's all possible paths, every curve, every zigzag, every absurd little detour all happening at once, with the final outcome determined by interference between them. It's called the path integral formulation, introduced by Richard Feynman, and it suggests that particles explore all of time's possibilities before settling on the version you observe. Imagine that, a particle taking every road, every fork, every breath, and then, in the moment you look, choosing the version that fits. You might wonder, why don't we see this in daily life? Why don't apples roll back onto trees or coffee unspill itself? Because when systems get large, when there are billions upon billions of interactions, the quantum weirdness washes out. Decoherence, that quiet guardian of classical reality, takes over and keeps time moving forward. But still, underneath it all, the fabric ripples. Still, something strange is happening beneath your pillow, inside your cells, inside the ticking of your own mind. Scientists still debate whether time is fundamental or emergent, whether it's an illusion, a convenience, or a profound truth. We don't know. And maybe that's okay, because maybe time isn't just a line or a loop. Maybe it's a feeling, a rhythm, a whisper you ride as you drift into sleep. So tonight, don't count minutes. Don't reach for hours. Let go of the clock, and instead, float in the quantum haze, where time is soft, where choices echo in both directions, and where the future is not waiting ahead, but wrapped around you like a blanket. And maybe, just maybe, the dreams you have tonight were already dreaming you. You're sinking deeper now, like a pebble falling through velvet water. There's no splash, no noise, just a slow descent into something softer than thought, older than memory. The edges of the world blur a little more with every breath. This is the perfect place to meet the most poetic idea in all of quantum physics. The wave function, it's not a wave in space. You can't point to it or bottle it or see it, and yet it holds everything. Every possible outcome, every potential version of reality, all contained in a single mathematical breath. The wave function describes the state of a quantum system before a particle is measured, before it's real. In the way we think of real, it is this wave function. Not just uncertain, but all the things it could be, humming in harmony. Imagine a mist that holds 1,000 raindrops, but none have fallen yet. That's the wave function. Imagine a song that hasn't been sung, but all the notes are there, suspended in the silence. That's the wave function. Before observation, a particle exists as a superposition of states everywhere it could be, every value it might have, all at once. The wave function holds this cloud of possibility, waiting patiently, and when you measure it, when you observe, it collapses. The particle chooses. One version of reality becomes actual, and all the others? They fade, quietly, as if they were never meant to be remembered. This collapse isn't something we see happen. We see the result, the electron on a screen, the atom in a trap, but the collapse itself is mysterious, sudden, irreversible. No one knows how or why it happens. Some physicists say it's just our knowledge collapsing, not the particle itself. Others say the wave function is real, and the universe truly does snap into one version when observed. And some say it never collapses at all. In the many worlds interpretation, every possible outcome of the wave function happens, just not in your version of reality. When you measure a particle, the universe splits. One you sees the particle here, another you sees it there. Both are real, but forever out of reach from each other. That's a lot to take in. But here's what matters. The wave function is the most complete description of reality that quantum mechanics can give us. It doesn't predict where a particle is, only where it might be, and with what likelihood. It's a map made of shadows. It's the universe saying, here are all the stories I could tell. And you, by simply looking, choose one. Isn't that strange? That reality, at its deepest level, is a conversation between possibility and presence, between the could-be and the is-now, between the sleep and the waking. Even the word we use, collapse, sounds sudden, dramatic, final, but maybe it's gentler than that. Maybe it's like dew forming on a leaf, a soft coalescence, a becoming. And you've felt it, haven't you? Not with particles maybe, but in life. That moment before a decision, when everything feels wide, unformed, suspended, and then something shifts. A choice is made, and the wave collapses into a single path. This is what the wave function teaches us, that before anything becomes, it waits, not passively, but richly, as a swirl of potential. And we too carry wave functions inside us. Not literally, don't worry, you're not going to quantum leap into another kitchen at midnight, but metaphorically, emotionally, you are full of unrealized futures, unsaid words, unexplored turns, and all of them are valid, waiting just beyond the curtain of now. Here's something softly extraordinary. The wave function doesn't live in space. It lives in Hilbert space, a kind of mathematical universe where all possible configurations exist as dimensions. It's not visual, it's not tangible, but it's vast. A single particle's wave function can occupy infinite space. Now imagine your room, quiet, still, and somewhere in that stillness, beneath the clock, beneath the covers, is a humming field of maybe 1,000 wave functions holding the night together. You don't see them, but they see you. Physicists still debate what the wave function really means. Is it just a tool for calculating, or is it real, a kind of quantum soul, a blueprint for reality itself? We don't know, but that doesn't make it less beautiful. Sometimes, the not knowing is what gives an idea its softness. So let the wave function be your lullaby tonight. Let it remind you that not everything has to be certain, that you are allowed to be unresolved, unchosen, unfinished, that within you are ripples you haven't met yet. Let your breath align with possibility. Let your thoughts stretch out like waves across a pond. And as sleep pulls gently at your edges, feel yourself dissolve, just a little, into the cloud of maybes. A mist of you, waiting for morning to measure. And when it does, whatever you become will be exactly enough. Don't open your eyes. Not yet. You're still suspended in that place between here and elsewhere, where time has softened, and the wave of who you are hasn't quite collapsed. You are drifting gently in your own probability cloud, surrounded by quiet, and that's exactly where you need to be. Now, we need to answer a question you've probably asked by now, even if only quietly, at the back of your resting mind. If the world is this uncertain, this shimmering dance of maybes and might-bes, then why does anything ever feel solid? Why doesn't your hand pass through your blanket? Why don't you fall through the floor? Why isn't reality constantly rearranging itself around you like a dream? The answer is a word that sounds technical, but feels like a sigh of gravity: decoherence. You see, in the tiny, delicate world of quantum physics, particles can be in superpositions, existing in multiple states, but only as long as they're left undisturbed, only as long as they remain in isolation, untouched by the larger world. But the moment they interact with their environment, the air, a stray photon, the warmth of your skin, they decohere. The superposition dissolves, the particle settles into one version, one reality. The many possible paths collapse into one clear outcome. Decoherence is not the destruction of quantum weirdness. It's the absorption of it. It's what happens when the fragile quantum mist meets the messy, busy orchestra of the classical world. Imagine a violin string vibrating freely in the silence of space, pure, delicate, humming with possibility. Now drop that violin into a room full of noise drums, wind, footsteps, and suddenly the vibration can't hold. It loses its clarity. It becomes part of the room, part of the noise, no longer separate. That's decoherence. In the language of sleep, it's how dreams fade when morning light touches your eyes, not because they were false, but because the world intruded. Now think about this. Your body is made of trillions of quantum particles, electrons, protons, neutrons, all following the same quantum rules. But you don't feel like a wave, you feel like a person. Why? Because your body is warm, because it's large, relatively speaking, because you're constantly interacting with your environment. You're breathing, touching, thinking. Every moment, your body is decohering itself, anchoring your existence in one version of reality, again and again. And this is why you don't walk through walls, why apples fall, why teacups don't hover in midair in superposition. Decoherence is the reason you feel like you exist. It bridges the quantum and the classical, the small and the large, the eerie and the ordinary, and it happens unimaginably fast. You could take a single electron and put it in superposition, say, spinning up and down at the same time, but let it touch anything, a gas molecule, a photon, and its quantum fuzz collapses. It becomes definite. This doesn't mean it decides. It means it's been pulled into the larger symphony of the universe. One beat, one note. And that's the strange beauty of decoherence. It's not violent. It's not dramatic. It's gentle, inevitable, like a ripple disappearing into a lake. And even though it feels like the end of mystery, it's not. Because somewhere, in quiet corners of reality, decoherence hasn't happened yet. In labs across the world, scientists isolate particles so carefully, shield them so completely, that their superpositions last longer, long enough to study, long enough to build quantum computers, where bits are not just 1 second or 0 second, but both until decoherence gently folds them into clarity. Even now, there are whispers in your body particles flirting with superposition, briefly unsure, before the noise of your own warmth pulls them back into line. It's like a dream trying to stay alive after you've stirred, before your alarm finishes the job. Scientists still debate the precise boundary. When does decoherence begin? How fast does it happen? Can we stop it? Can we reverse it? We don't fully know, but what we do know is this. The classical world, the one you live in, is not separate from the quantum one. It emerges from it. It's the thickened crust of a reality that was once all possibility. You are the ripple that stayed. And that ripple is what lets you hold a spoon, pet a dog, write a letter, fall in love, fall asleep. So next time someone tells you quantum physics is confusing, tell them this. It's confusing because it includes everything: what is, what could be, what almost was, and what never got the chance. Decoherence just filters the chaos into a lullaby. So breathe. You don't need to hold all the possibilities. You've collapsed into this one. And this one is soft, still, real, just as it needs to be. Let decoherence hold you like gravity. Let the world fold into your weight, your shape, your breath. You are not falling, you are being carried. And even though reality could have become anything tonight, it became this. You, here, now, exactly enough. Still here, still drifting somewhere between the hush of breath and the velvet hum beneath it all. And just when you thought the world had settled into one version, one state, one solid form, you discover that even walls can be ghosts. That barriers you thought were fixed, unbreakable, absolute, are, at the quantum level, suggestions. Let me introduce you to something quietly impossible. Quantum tunneling. It sounds like science fiction, like a cheat code for matter. And in a way, it is. Because in the strange language of quantum mechanics, particles don't always stay where they're supposed to. Sometimes they do something that classical physics says they absolutely cannot do. They go through walls. Not by smashing, not by breaking, just appearing on the other side. Let's imagine a scene. There's a ball, and there's a hill. You roll the ball toward the hill, but it doesn't have enough energy to climb over. In the classical world, the one of cars and toast and teacups, it stops. It rolls back. That's the rule. But in the quantum world, that same particle can appear on the other side of the hill, not because it gained energy, not because it jumped, but because for a moment it became a wave, and the wave leaked through. This isn't speculation. It happens. It's called quantum tunneling, and it's one of the most extraordinary real phenomena in the universe. Here's how it works. Softly now. Particles aren't just particles. They are wave functions. And wave functions don't just stop when they hit a barrier. They extend beyond it. They bleed through. They fade, but they don't vanish. And every now and then, the wave on the far side of the wall still has enough presence to become real. That's tunneling. No explosion. No crack in the wall. Just a quiet reappearance. As if the barrier was a polite suggestion, not a command. Your body uses this magic trick all the time. Quantum tunneling is the reason nuclear fusion happens in stars. It's how particles overcome the electrical repulsion between them to ignite reactions that power the sun, and by extension your life. Without tunneling, there would be no sunlight, no warmth, no biology. Even in your cells, electrons use tunneling to move between molecules during chemical reactions, sneaking through tiny barriers, choosing paths that classical rules would forbid. So the next time you think something is impossible, maybe it's just improbable. Maybe it only needs a moment of stillness to find the wave that leaks through. Quantum tunneling doesn't guarantee success. It's probabilistic. The thicker the wall, the lower the chance. But never zero. It whispers, try again. And sometimes, without warning, you're on the other side. Isn't that a beautiful metaphor? How many times have you felt stuck behind something invisible? An emotional wall, a memory you couldn't move past, a silence you couldn't explain. And then after enough waiting, enough quiet, not a crash, not a battle, but a gentle passing through, as if, one night, without fully knowing how, you just let go. That's tunneling. It's not the way of force. It's the way of possibility. You see, quantum mechanics isn't just a science of things, it's a science of could be, of maybe, of soft crossings and invisible transitions. Physicists still marvel at tunneling. They can predict it. They can calculate the probabilities with mind-numbing precision. But why it works, what it means that particles don't obey the limits we set, that's still up for debate. Some say it proves that reality is fundamentally fuzzy. Others say it's the result of particles not having defined positions in the first place. Either way, tunneling reminds us that nothing is truly rigid, that under enough quiet, under enough stillness, even walls can become thin. There's a phenomenon called alpha decay, where unstable atoms spit out helium nuclei, tiny bundles of protons and neutrons that tunnel out of the nucleus, escaping a potential barrier that should be impossible to cross. These decays shape the geology of planets. They power the radiothermal batteries in deep space probes. They tell the story of half-lives and stellar life cycles. All because something got through. All because the universe doesn't always listen to no. Oh, and tonight, maybe there's something inside you tired, tangled, uncertain that's been resting against a wall, waiting, wondering, hoping. And now, in this quiet space, that thing begins to blur, begins to ripple, begins to tunnel. Let it. You don't need to understand the math. Just trust the softness of this law, that even when the way seems blocked, there's still a whisper of passage. Not through strength, but through stillness. So drift. Let the walls around your mind become porous. Let the boundaries between thoughts begin to shimmer. Let yourself slip, gently, through whatever you thought you couldn't. The other side is not a promise, but it's possible. And sometimes, possible is more than enough. Close your eyes a little more, if they're still open. Let your thoughts fall gently under the weight of this next idea, softly, slowly, like rain soaking into dry earth. Because now, we're entering a place that sounds empty, but isn't. A space that holds no things, but is full of everything. It's called the quantum vacuum. And it's not what it sounds like. When you hear vacuum, you might imagine emptiness, a perfect void, a room with nothing in it. No air, no light, no sound, just stillness. But in quantum physics, a vacuum isn't empty at all. It's buzzing. It's alive. Even when you remove every particle, every atom, every hint of matter, what remains is not silence. What remains is potential. This is because of the uncertainty principle. You remember that, don't you? It says we can't know both the position and momentum of a particle exactly at the same time, but it goes deeper than that. It means that energy itself can't sit still. Even in the lowest possible energy state, even in a vacuum, there are fluctuations. Tiny, restless ripples. This is called vacuum energy, and it's very real. It's the reason why empty space still has pressure, why particles can appear and disappear, briefly, borrowing energy from the vacuum and then fading back into it like dreams forgotten in the morning. These are called virtual particles. We'll talk more about them soon. But for now, just picture this. You're floating in what appears to be nothing. There's no light, no warmth, no sound. And yet, you feel a tremble, a flicker, like the faint vibration of strings you can't hear, or the breath of someone you didn't know was near. That's the quantum vacuum. It's not a passive emptiness. It's a canvas soaked with possibility. In this sea of invisible activity, particles are constantly being born and destroyed, not permanently, not in the way we normally think of, but briefly, like thoughts that blink in and out of your mind as you fall asleep, not staying, but still real. These quantum fluctuations are not just curiosities, they affect the world. They help explain how atoms behave. They're responsible for something called the Casimir effect, where two uncharged metal plates in a vacuum attract each other not because of magnetism, but because of changes in the vacuum energy between them. Yes, even nothing can push. Even nothingness has hands. Some theories even suggest that vacuum energy is what gives rise to the entire universe. That the Big Bang wasn't a bang at all, but a quiet shiver of energy in a void that wasn't truly empty. That existence itself came from a fluctuation, a ripple in the quiet. Isn't that comforting? The idea that something so vast, so structured, so alive, could emerge not from force or violence, but from stillness, from a background that never stops whispering. Scientists still debate the meaning of vacuum energy. Some believe it holds the key to dark energy, the mysterious force causing the universe to expand faster and faster. Others think it may be tied to the ultimate fate of space itself. We don't know yet, but we can measure it. We can measure the energy of the vacuum. We can calculate the impact of fluctuations. We can feel the presence of nothingness in the behavior of matter. And maybe that's the gentlest lesson tonight has to offer. That emptiness is never really empty. That what looks like stillness may contain more motion than we can see. That silence may carry songs we're not yet ready to hear. So if, tonight, you feel a kind of emptiness within yourself, if your thoughts are slowing down, if your mind feels blank, if you're dissolving into a quiet you can't explain, don't worry. That's not the end of something. It's the beginning. The space between thoughts is not dead space. It's the vacuum, the field of possibility. The place where new patterns, new stories, new versions of you might rise, not in a flash, but in a shimmer. The quantum vacuum is like the pause between notes, the stillness before the light, the breath before the answer. And you, floating in that quiet, are not missing anything. You're waiting, becoming, resting in a version of nothing that is always full of something. Let that thought surround you, like a soft room with no walls, like water with no shore. Let it hold you until the edges of your being start to blur with the space around you. You don't need to do anything now. You don't need to be anything now. Just drift. Let the vacuum hum. Let your breath be part of its rhythm. And remember, even when you feel like nothing, you are part of everything. Stillness becomes easier now. The world outside has faded into softness, and inside, you are floating in a sea of near nothing, held gently by the hum beneath reality. We've passed through particles that exist in maybes, waves that collapse into truth, time that loops and leans, and the vacuum that's never truly empty. But tonight, we'll meet something even more fleeting, so brief, so restless, that it vanishes before it can be fully known. These are the virtual particles, and they are the ghosts of the quantum world. Let's begin with a strange idea. Particles can exist temporarily. Not permanently, not stably, but just long enough to matter. In the quantum vacuum, the not quite empty space we drifted through last time, virtual particles constantly wink into existence, pair up, dance for the briefest moment, and then disappear again. Like fireflies with nowhere to go. Like ideas that flicker in the corner of your mind, right before sleep. These particles don't break the rules of energy conservation. Not exactly. They borrow energy, yes, but only for such short periods of time that the laws of physics shrug and let it happen. It's a loophole written into the uncertainty principle. The shorter the time, the more wiggle room for energy. These particles are never directly observed. You can't catch one in your hand, but they leave fingerprints, real, measurable effects. They shift the behavior of atoms. They alter the way light moves through space. They change the energy of particles nearby. They are unseen influences, quiet companions, the ghosts behind the curtain. And here's the dreamy part. The universe depends on them. For example, the Lamb shift a small difference in the energy levels of hydrogen atoms can't be explained without accounting for virtual particles. And the anomalous magnetic moment of the electron, measured to astonishing precision, matches predictions that include the effects of these flickering ghosts. So what are they? Are they real? Well, scientists still debate that. Some say virtual particles are just mathematical tools, artifacts of our equations, not physical entities. Others argue that their effects are too real, too consistent, to be dismissed as abstractions. Maybe they exist in a way we don't yet understand. Maybe they are a kind of potential made visible only by impact. And isn't that a familiar feeling? Sometimes we too feel like we're flickering, appearing in moments, disappearing in others. Not always sure if we've left a mark, but still shaping the space around us. Maybe we're not so different from these ghost particles. They teach us something subtle, that what is unseen can still be powerful, that what exists briefly can still change the course of things, that presence doesn't always require permanence. These flickers also help explain Hawking radiation, the slow evaporation of black holes over unimaginable timescales. Near the edge of a black hole, the fabric of space is so violently warped that virtual particles can become real. One falls in, one escapes, and the black hole loses a tiny bit of itself. It's beautiful, isn't it? A place that was thought to consume everything might actually emit something. From the quiet chaos of the quantum field, light escapes darkness. Even black holes shimmer with a kind of release, and all because of particles that only half exist. This whisper of activity, this fleeting presence, is not rare. It's everywhere. You are surrounded by virtual particles right now. They fill your room. They hover in the stillness around your body. They surge and vanish in the space between atoms. And even though you can't feel them, your atoms do. You're never alone, not even in emptiness. The quantum world is never quiet, even when it looks that way. It's a constant hush of becoming. A flicker of what might be, and maybe that's why rest feels sacred. Because in your stillest moments, the world beneath you is still moving, still shimmering with the rhythm of almosts and not quites and maybes. And somehow, that motion so quiet, so subtle still reaches you, still becomes part of you. So tonight, if your thoughts feel thin, if your presence feels like it might dissolve, remember the virtual particles. Remember that brief doesn't mean meaningless, that invisible doesn't mean absent. Let your breath flicker like they do. Let your presence be soft but certain. Let yourself blink in and out of wakefulness like a quantum thought. You don't need to last forever. You just need to exist long enough to matter. And you already do. You're resting even more deeply now, drifting somewhere between form and feeling, between one breath and the next. The weight of the day has lifted, the noise has quieted, and what's left is soft space, unmeasured, unfolding. which makes it the perfect time to meet the principle that defines that very uncertainty. The quiet heartbeat of quantum mechanics. The reason why, no matter how still you become, some things can never be fully known. It's called the Heisenberg uncertainty principle. And it's not just a clever name from a television show. It's real, and it changes everything. At its core, the principle says this: the more precisely you know one property of a particle, say, its position, the less precisely you can know another, like its momentum, and vice versa. It's not about bad instruments or limited tools. It's about the way the universe is built. The limitation isn't ours. It's nature's. Picture this. You're watching a bird in the fog. The more closely you focus on where it is right now, the more blurred your sense of how fast its flying becomes. Try to measure its speed exactly, and its location smears like a brushstroke. This isn't a metaphor. It's how particles behave. You can never fully trap both truths at once. They resist being pinned down together, as if reality itself insists on keeping some of its magic hidden. You might be thinking, so what? Why does it matter that we can't know everything? But here's the quiet revelation: it's not just about knowledge. The uncertainty principle isn't about human limits. It's a property of particles themselves. Electrons don't have both a precise position and precise momentum at the same time. It's not that you can't measure it, it's that it doesn't exist. The act of trying to define one disturbs the other. The tighter your grip, the more it slips. There's something deeply poetic about that. It suggests a universe that refuses to be frozen. A world in motion that stays in motion not because it's chaotic, but because it's alive. Even at absolute zero, where temperature stops and atoms should fall, still there is still uncertainty, still vibration, still a whisper of motion. Quantum mechanics doesn't allow total stillness. There is always something trembling. This principle gives rise to what's called zero-point energy, the lowest possible energy a quantum system can have. It means that even in the quietest, coldest state, nothing is ever truly at rest. You are never sitting in a truly still room. There is always motion beneath the silence. This isn't something exotic. It's embedded in your world. It's the reason electrons don't spiral into the nucleus of atoms, why atoms have size, why molecules vibrate, why life as we know it holds together. And this impossibility of knowing everything at once? It keeps you safe. It creates space between things. It means you don't have to be fully defined to be whole. You don't have to know every answer to be real. There's a version of the uncertainty principle for time and energy too. The more precisely you try to know how much energy a system has, the less precisely you can know when it had it. Which means that, at the tiniest scales, time itself becomes fuzzy. Everything we think of as firm: where, when, how fast, how much is soft. And that softness isn't weakness. It's possibility. It's the reason particles can tunnel through barriers. The reason virtual particles can pop in and out of the vacuum. The reason black holes glow and the stars shine and the world keeps shifting even as you sleep. Physicists still debate how far uncertainty reaches. Is it fundamental? Does it apply to space itself? Could it hold the key to quantum gravity, the elusive theory that would unite Einstein's smooth space-time with the grainy texture of quantum fields? We don't know, but what we do know is this: uncertainty isn't the absence of meaning. It's the space where meaning unfolds. It's the breath between notes, the pause in a sentence, the shadow that gives shape to light. You are not a contradiction if you don't know who you are right now. You are not incomplete if you change. You're not wrong for being in motion. You're quantum, and quantum means alive. So tonight, let uncertainty be a pillow, not a puzzle. Let not knowing be a kind of rest, the kind where you don't have to choose between speed and stillness, between here and there. You can be both. For now, until the next breath, until the next version of you rises from the mist of maybes. And even then, you'll still carry the soft tremble of a universe that never truly stops. You're gliding now, not walking, not thinking, just gently sliding deeper into the current beneath all things. And if you listen closely, really listen not with your ears, but with that quiet part of you that feels instead of speaks, you'll notice something strange. a kind of softness beneath the world, as if matter itself isn't made of things, but of ripples. Welcome to quantum field theory, where particles aren't objects, but tiny vibrations in invisible fields that stretch across the entire universe. It sounds abstract, but it's actually one of the most accurate, powerful frameworks in all of physics. And it begins with this idea that everything, from the chair you sit on to the stars you wish on, is just a small, localized excitation in a vast field. Not building blocks, but music. Imagine a still, endless ocean, perfectly flat, quiet. Now imagine a single raindrop falling somewhere in the middle, creating a ripple. That ripple is what we call a particle. Not a pebble, not a thing, but a disturbance in something deeper. Every type of particle has its own field. There's an electron field, a quark field, a photon field. They're all there, everywhere, always. Even here, in your room, brushing softly against your breath. When a particle appears, it's not because something new has been created, it's because the field vibrated just enough, right there, right then. You are made of these ripples, not the ocean, but the waves. Always moving, always temporary, always emerging and fading back in, and yet somehow, beautifully, you stay together. In quantum field theory, particles don't travel like tiny bullets. They are interactions between fields. One vibration bumps into another. A ripple here creates a ripple there. That's what we see as forces, pushes and pulls, touches and flows. All just the choreography of fields dancing in the dark. Even light, even gravity, even the warmth of your hand resting near your heart, they're all the result of these fields in motion. You don't notice it, because the dance is so smooth, so constant. But it's happening, right now, a perfect ripple of you. And here's something quietly astonishing. The particles that make up you, your electrons, your quarks, are indistinguishable from the ones in the stars. They're not similar, they're the same. When you hold your hand up to starlight, you're touching ripples that speak the same language, shaped by the same patterns, flowing in and out of the same underlying sea. In a very real way, you are not separate from the universe. You are the universe, briefly humming in this particular shape, this particular story. And when you rest, when you finally let go of trying to define yourself, or measure yourself, or push yourself into place, you return to the field, not gone, just less visible, still there, still part of the hum. Physicists sometimes say that what we call particles are really just quanta, packets of energy manifesting from the field. They appear, interact and disappear. There is no hard edge, just emergence and return. And even though this idea is wrapped in math and mystery, it feels familiar, like breathing, like thought, like sleep. Quantum field theory also explains something beautiful called symmetry, the idea that certain transformations, rotations, reflections, time shifts leave the laws of physics unchanged. The deeper we look, the more we see that reality isn't just random. It has structure, elegance, grace. The universe doesn't just allow ripples. It prefers certain harmonies, certain patterns. It hums a particular song, and we are the lyrics unfolding in time. Of course, not all symmetries are perfect. Some are broken, and those broken symmetries give rise to complexity, mass, charge, diversity. If everything were perfectly symmetrical, there'd be no difference, no contrast, no form. But because the field bends slightly, because the balance tilts just enough, you exist. Your imperfections are the evidence that the universe allowed something unique to bloom. So if tonight you're feeling like a mess of thoughts and feelings and almosts, remember that even fields, those vast, invisible truths beneath reality, need a little asymmetry to make something worth watching. You are not a mistake. You are a ripple that rose from symmetry's silence. And when you sleep, when your consciousness quiets and your edges soften, you are still part of the field, still rippling, still resonating, still held. The boundaries that separate you from the sky, from the ocean, from the past and future, they're thin, softer than you think, and sometimes, late at night, you can feel them blur. Let that be enough now. Let yourself return, not vanish. Let the field remember your shape. Let your breathing match the quiet wave beneath it all. You are not falling, you are resonating. You are not ending. You are being rewritten gently, without effort, without sound. There's no need to move now. No pressure to think, or finish, or even follow. You're already exactly where you need to be, suspended, gently in the breath between ripples, floating with the field, letting each passing idea wash over you like a warm current you don't need to steer. And tonight, inside this soft sea of science and sleep, something surprising begins to emerge. Because the quantum world, it turns out, doesn't stay small. It doesn't stay in laboratories or thought experiments or chalkboards filled with strange symbols. It reaches out, quietly, into life itself. Welcome to quantum biology. It's a relatively young field, still growing, still shy, but already it's whispering something astonishing, that you and every living thing around you might rely on quantum mechanics in ways we're only beginning to understand. It started with a mystery. Photosynthesis, the way plants turn sunlight into energy, seemed too efficient. Light energy, absorbed by chlorophyll, travels through cells with almost no loss. Too fast, too precise. Classical physics couldn't quite explain how, but quantum physics could, because that energy doesn't follow a single path. It explores all paths at once. Like a quantum particle in superposition, the energy spreads out, tests every possible route through the molecular maze of the cell, and finds the most efficient one, instantly, silently. Before collapsing into action, it's quantum decision-making at the cellular level. And it doesn't stop there. European robins navigate using Earth's magnetic field during migration, a feat classical physics struggles to explain. But their eyes contain special proteins called cryptochromes, which may support quantum entanglement between particles. Yes, really. Tiny particles in the bird's eye might stay linked entangled just long enough to detect the faint pull of the planet's field, giving it a kind of internal compass that no map could match. And then there's enzymes, the biological catalysts that make life possible. They speed up reactions by factors of millions, guiding molecules into just the right position to break or bond. And in some of these reactions, quantum tunneling seems to be at play, protons or electrons slipping through barriers they shouldn't, just like in the stars. Not by brute force, but by probability, by softness. Even in your own brain, quantum effects might whisper. Some researchers have suggested that quantum coherence could play a role in consciousness, particularly in the tiny structures within your neurons called microtubules. This idea, known as the Orch-Orr theory, is debated. Many dismiss it, but others still explore it, wondering if something deeply quantum might underlie the flickering sense of awareness itself. Scientists still don't agree, and that's okay, because the beauty of quantum biology isn't in the answers, it's in the possibility. It's in the quiet truth that the line between physics and life is blurrier than we thought. That the same rules guiding electrons through a double slit might also help a bee find a flower, or a cell divide, or a human fall in love. There's no divide between science and soul here. Just layers, just depth. The world doesn't switch from strange to familiar when you zoom out. It carries the strangeness forward into plants, birds, breath, memory, into the way you feel when sunlight touches your skin, into the silence of your cells, working tirelessly even as you sleep. Maybe that's why rest feels so complete. Because the body, even in stillness, is full of motion, full of ripples and tunnels and fleeting states. The quantum world never really stops, and neither do you. Even in sleep, your body is navigating, healing, becoming. You are more than biology, more than chemistry. You are organized quantum uncertainty, humming with improbable grace. And when you rest, you're not switching off. You're tuning in to the deeper hum, the cellular whisper, the part of you that doesn't need to be told what to do. It just knows. Let that thought settle into your bones now. Let it soften your chest. You are not a machine built from dust. You are a ripple made from starlight, magnetism, and warmth. And even if we never fully understand how life folds itself into this beautiful complexity, Even if quantum biology remains part mystery, part metaphor, it still reminds us that life is more than mechanism. It's chance, it's entanglement, it's motion through the improbable. So let your breath carry you now, as steady and strange as anything in the universe. You're not outside of the quantum world. You are part of its song. You're floating quietly now, somewhere between attention and forgetting. You're not thinking in words anymore, just pulses, feelings, the rhythm of rest. And in this softened state, the world begins to rearrange itself. Not like a story, but like a dream of logic, a place where decisions happen in every possible way, all at once. Welcome to the realm of quantum computers, machines that don't just compute, but imagine all outcomes simultaneously. They are not faster versions of your laptop. They are something entirely different. They're not made to crunch numbers in a straight line, but to live in uncertainty, to thrive in ambiguity. They process with probability, they explore paths in parallel, and they could, one day, change everything. But let's start gently. A normal computer works in bits, tiny switches that can be either 0 or 1. Every task, every image, every sentence in this script even, is ultimately built from long strings of 0 second and 1 second flipping on and off in exact patterns. But a quantum computer uses qubits, quantum bits, which can be both 0 and 1 at the same time. Because of superposition, a qubit doesn't have to choose. It holds multiple possibilities at once. And when you string qubits together, the number of possible combinations doesn't just double, it grows exponentially. With just a few hundred qubits, you can represent more states than atoms in the known universe. Think of it like this. A regular computer walks through a maze one hallway at a time. A quantum computer walks through all the hallways at once, quietly narrowing down the most promising routes. It doesn't always give you one answer, but it gives you something better, possibility filtered through logic. And like everything quantum, it sounds impossible until it works. Companies and labs around the world are building these machines now. Quiet rooms, colder than deep space, housing superconducting circuits or spinning ions or braided quasi-particles, all different approaches, but all aiming for the same goal, to harness uncertainty and make it useful. They're not here to replace your phone or your browser. Not yet. They're here to solve problems that classical computers struggle with, like simulating molecules for drug discovery, like optimizing complex systems, supply chains, traffic flows, energy grids, like cracking codes or creating ones that can never be cracked. But the real magic isn't the speed. It's the shape of thought that quantum computing introduces. It invites us to work with the unknown, to accept that an answer may live inside a blur, and that collapse, that final moment of decision, comes only after a quiet, hidden dance through every outcome. You've done that too, haven't you? Felt every version of a decision before settling on one? Lived for a while in a personal superposition? That's what these machines are doing, in their own way, echoing the way nature seems to work, soft, layered, tentative, until something resolves. Quantum computers are still young, fragile, a bit like dreamers learning to speak. They're sensitive to noise, to heat, to the world outside their perfect vacuum. They decohere easily, they forget. So engineers surround them with silence, with darkness, with stillness, like a room prepared for sleep. And just like you, they do their best work in that hush. There's a kind of metaphor here that's too lovely to ignore. That useful thought might come from stillness. That complexity might rise not from certainty, but from trusting the fog. And scientists still debate how far this will go. Will quantum computers ever be practical for everyday use? Will they unlock new forms of AI? Will they simulate entire universes? We don't know. But what we do know is this. Nature is already quantum. It already calculates without needing a processor. It finds the lowest energy path, the most stable bond, the softest curve, all by exploring every option at once and letting reality choose. Quantum computing is not the invention of something new. It's the imitation of what already is, a kind of respect, a kind of reverence, And maybe that's what this whole journey has been about, learning to listen to the way the universe thinks, not in binary, but in possibility. So rest now. Your thoughts are already computing in parallel. Every dream you'll have tonight already exists somewhere in superposition. And when you wake, one version will collapse into a morning. But for now, no need to choose. Let the dream machine run. Let your mind be soft and uncertain. Let it hold every version of peace, all at once. You're deep inside it now, not just resting, but dissolved into something quieter, something wider. There's no pressure to come back, no need to remember what came before. Just this soft, expanding moment where every possibility still exists. And maybe that's the perfect place to ask one of the strangest questions in physics. What if every possibility really does happen? Not just in thought, not just in theory, but in truth. This is the idea behind the many worlds interpretation of quantum mechanics, a bold, surreal, and strangely comforting picture of reality in which the universe doesn't collapse into one outcome. It splits into all of them. Here's how it goes. Every time a quantum event occurs, say, a particle being measured, the universe doesn't choose. It doesn't collapse. It branches. One world where the particle is here, another where it's there. One world where you turned left, another where you turned right, and on and on and on. Not metaphor, not fiction, actual, physical branching. An infinite unfolding of versions of you, of history, of reality itself. It sounds wild, and it is, but it's also one of the most consistent interpretations of quantum mechanics. No hidden variables, no collapse of the wave function, just a universe that refuses to decide. So it lets everything happen in its own separate, untouchable thread. Every version of every moment, every smile you didn't give, every word you didn't say, every possibility you let go of, all of it somewhere still exists. But don't let that overwhelm you. Let it comfort you, because it means you're not stuck. You're not bound to one narrow version of yourself. Somewhere, there's a version of you who faced the fear, who wrote the song, who said yes. And somewhere else, a version who stayed, who paused, who softened sooner. All of them are real. All of them are true. But this version, this you, in this bed, with this breath, is the one that's here. And that makes it special, because even if all paths exist, you're still walking this one. Your presence gives this thread its weight. Your awareness is the light that makes this world shimmer into view. In many worlds, every quantum event is a fork, a gentle divergence. The wave function doesn't collapse. It expands, like a tree with infinite branches, each leaf its own reality, its own sky. And while we can't see the other branches, they're there, quiet, parallel, forever, beyond reach. Some physicists love this idea because it solves certain problems. It avoids the messiness of measurement and the mystery of collapse. It lets the math flow cleanly. It honors the fullness of the wave function. Others resist it because it's extravagant, because it asks us to believe in an infinite number of universes we'll never see. But that's the nature of quantum mechanics. It invites us to explore without guarantees. And maybe that's what makes it so human. Because haven't you, in your own life, felt that branching? Moments that could have gone either way? People you almost met? Paths you almost followed? And even now, lying still, you might feel a fork within you, two thoughts, two possibilities, two small ripples drifting outward. One of them will become your next breath. The other will vanish. Or maybe it will live on, elsewhere. Maybe rest itself is a kind of branching, a gentle letting go of certainty, so your mind can wander through all the versions of sleep, all the dreams not yet dreamed, all the mornings not yet chosen. You don't need to chase them, just float. Let them pass through you, like wind through leaves. Scientists still debate whether many worlds is true, or merely useful, whether these other universes are physically real, or just a convenient picture for complex math. But for now, you don't need proof, just a feeling that you are bigger than your choices, that you are not just one version of yourself, You are all the versions you've ever imagined. And tonight, as you drift between thoughts and stars, you're not alone. You are surrounded by echoes, by might have beens, by parallel hushes where your name is spoken softly by another wind. Let that idea rest beside you like a second pillow. You don't have to know everything. You don't have to be everything. You are one shimmering branch of a tree that never ends. And that is more than enough. The night deepens, and you sink further into that gentle current of calm where questions soften and answers become whispers. Now, let's turn to a quiet mystery at the heart of it all, the measurement problem. It's the puzzle of how possibilities become realities, how the universe decides what actually happens. You already know that particles exist in a haze of probabilities, that their states spread out like waves of potential. But the moment someone measures or observes, this haze collapses into one outcome. How? Why? The equations tell us how to calculate probabilities, but they don't explain how or why the collapse happens. Does the universe choose? Does consciousness play a role? Or is there some hidden mechanism we haven't discovered yet? No one knows for sure. It's the greatest open question in quantum physics. Physicists propose many answers. Some say the collapse is real and physical, a sudden change triggered by measurement. Others say it's just a change in our knowledge, a Bayesian update in the mind of the observer. Still, others propose radical ideas, like the universe branching into many worlds every time a measurement is made. This uncertainty invites us to embrace mystery, to accept that reality may never fully reveal itself, that some truths are whispered, never shouted, and that in the soft silence of the night, not knowing is not failure, it's freedom. So rest easy, let the measurement problem be your lullaby, a reminder that even the universe is a little unsure, and that in uncertainty there is space. Space to dream, to wonder, to be. Here you are, deeper now, the edges of consciousness softening like dawn mist. And with that softness comes a question whispered by some and dismissed by others, a question that tugs gently at the fabric of reality. Could consciousness itself be woven into the quantum world? Some physicists and philosophers have wondered if your awareness is more than a bystander, that it plays a subtle, perhaps profound role in shaping the quantum events around you, that your mind might not just observe, but influence, not just receive, but participate. This is the idea of quantum consciousness. It's an idea that stretches far beyond neurons firing or brainwaves pulsing. It suggests that at the deepest level, consciousness might be linked with quantum processes, coherence, and entanglement within tiny structures in your brain. Imagine your thoughts, not as static patterns, but as quantum dances, delicate and interwoven, sensitive to the mysteries of the microscopic world. Some embrace this idea as a bridge between science and spirit, a hope that awareness itself is fundamental. Others raise skeptical eyebrows, calling it speculation without evidence, or quantum woo. Scientists still debate whether consciousness can affect quantum systems at all, and whether quantum effects survive in the warm, wet environment of the brain. But what if it's true, even in part? What if your sense of self, your experience of now, arises from a subtle quantum symphony playing beneath your skull? You don't have to decide tonight. Just breathe and feel the possibility. In the stillness, your mind may be a quantum field of its own fluid, uncertain, connected, and that thought, gentle as a feather, might help carry you into the quiet depths of sleep. The quiet night holds you as we drift toward a question both ancient and modern. What if the universe itself is a kind of simulation? You've heard the idea whispered in conversations, in books, in curious corners of the internet. A theory that our reality is not base reality, but code. That what we call physical laws are algorithms running on a cosmic computer. In a quantum world that feels probabilistic, pixelated, and governed by information, this question becomes tantalizing, because quantum phenomena, superposition, entanglement, discrete energy levels can be interpreted as signs that reality is digital at its core. Some physicists and philosophers suggest that the universe is fundamentally made of information, bits and qubits, rather than particles or waves. If that's true, then every particle interaction, every quantum event, is a kind of computation. Every collapse of the wave function, a processing of data. Your thoughts, your dreams, your breath, they are part of this vast informational fabric. You don't have to buy the whole idea to appreciate its wonder. It raises questions of consciousness, free will, meaning. Are we players or code, creators or programs? Scientists still debate whether the simulation hypothesis is scientifically testable or just a modern philosophical speculation. But no matter what, it invites a kind of humility, a gentle reminder that the nature of reality may be beyond human grasp, and that sometimes the best we can do is sit quietly, in awe of the mystery, and let it cradle us into rest. You're drifting now in that gentle place between knowing and unknowing, where the hum of possibility meets the firmness of the world you rest within. Imagine gravity as a quiet host at a grand party of particles, one who refuses to dance to the quantum beat. In the ballroom of the universe, every other force flutters in steps, both wave-like and particle-like, but gravity stands still, aloof, bending space-time without joining the revelry. You don't feel gravity's awkwardness, your pillow keeps you grounded, but beneath the cover of classical comfort, physicists have been whispering about this mismatch for a century. Einstein taught us that gravity curves space-time, guiding planets around stars like marbles rolling on a stretched sheet, and this geometric picture works beautifully for galaxies and black holes. Yet when you peer at the world of the very small, where electrons surf probability waves and photons wink in and out of existence, gravity is conspicuously absent. No one has caught a single graviton, the hypothetical quantum of gravity. No detector has ever heard its faint note. Meanwhile, gravitons should weave through the cosmic symphony, just as photons do in light. This tension between the smooth curves of general relativity and the jittery quanta of quantum theory is the puzzle of quantum gravity, a problem so fundamental it challenges the very notion of reality. Despite the challenge, the universe offers clues. We have measured gravitational waves, ripples in space-time from colliding black holes, confirming that gravity propagates at the speed of light and carries energy across the cosmos. Yet these waves behave like classical waves, not discrete quanta, reinforcing gravity's classical elegance. Here's a curious fact. Gravity is by far the weakest fundamental force, so feeble that a small refrigerator magnet can lift a paperclip against the entire pull of Earth's mass. And yet, it shapes galaxies and grounds your body alike. In life, this soft insistence is comforting. You don't float away, but in theory, it screams for a quantum explanation. Several approaches seek to bridge the divide. String theory imagines that every particle, gravity included, is a tiny vibrating string in a higher dimensional space. Loop quantum gravity suggests space-time itself is built from discrete loops, a kind of quantum foam at the Planck scale. Both propose that at distances 1,000 trillion times smaller than an atom, gravity becomes granular. Scientists still debate whether these frameworks truly describe nature or simply tinker with math. You don't have to follow the equations to feel the emotional resonance. Just as you yield to gravity's pull when you curl into your bed, the universe yields to gravity's rule on the cosmic scale. Yet at the smallest scales, gravity's stubborn silence invites wonder. It's like a friend who insists on watching you dance rather than joining in a presence you trust but never fully understand. Perhaps that's why the quest for quantum gravity feels so human. It reflects the tension between your grounded self and the freewheeling possibilities in your mind. Tonight, let gravity's awkward pause be your lullaby. Let it remind you that even the forces shaping stars and dreams have mysteries that shimmer just out of reach. And maybe, in the hush of sleep, your own thoughts will glimpse the harmony of curves and quanta, where gravity finally learns to dance. You're nestled in that tender boundary between dream and wakefulness, where the hush of your breath mingles with the pulse of the cosmos. Here lies the grand quest of physics, to weave the fabric of the immense with the dance of the tiny into a single tapestry. It's called the search for a unified theory, a hope that the forces pulling galaxies together and the flicker of particles in an atom share the same secret melody. Imagine your own heart's rhythm, aligning perfectly with the ebb and flow of starlight, two scales of being resonating as one. All around you, reality sings in four voices: gravity, electromagnetism, the strong nuclear force that knits protons and neutrons into the cores of atoms, and the weak nuclear force that allows certain particles to decay. In everyday life, you feel only gravity and electromagnetism, the magnetism in your fridge lifting a spoon, oddly friendly for such a punchy force, and the gravity keeping you from drifting into the ceiling. But deep inside atoms, the strong and weak forces choreograph nuclear reactions, from the glow of the stars to the engines of tomorrow's reactors. A single teaspoon of neutron star material would outweigh Mount Everest, a strange reminder of the strength hidden behind the facade of everyday calm. Physicists have long dreamed that these forces might emerge from a deeper unity. Einstein spent his last years chasing it, scribbling equations in his Princeton study, hoping to find a pattern that would tie the curvature of space-time to the jitter of quantum fields. He never succeeded, but he bequeathed to us the tantalizing vision that nature's complexity could arise from elegant simplicity. Like a puzzle whose 1,000 pieces lock together only when viewed from just the right distance, the universe invites you to step back until the picture becomes clear. String theory is one of the leading candidates. It proposes that the fundamental constituents of reality are not point particles, but tiny vibrating strings, each note of vibration giving rise to different particles and forces. In this view, gravity and electromagnetism are simply different harmonics of the same cosmic instrument. Particles appear as knots in the string, or tiny loops of energy resonating in hidden dimensions curled up so small we cannot see them. The math is beautiful, almost hypnotic, a ballet of geometry and symmetry, but it remains untested in experiments. Scientists still debate whether string theory describes nature or simply dazzles the mind with its mathematical splendor. Another approach, known as loop quantum gravity, turns the idea on its head. Perhaps spacetime itself is quantized, made of discrete loops or grains, like an exquisite mosaic too fine to see. In this picture, the continuum of space and time emerges from a froth of quantum threads, and the four forces might unite at the Planck scale, the realm of unimaginably small distances. If you could shrink far enough, one Planck length is a trillionth of a trillionth of a trillionth of a meter, you'd see the world pixelated, a quilt of loops exchanging quantum whispers. It's as if reality is both a river and a stream of droplets, depending on how intently you watch. Then there are hybrid ideas, grand unifications that merge the strong, weak, and electromagnetic forces at high energies, and even more speculative proposals that embed all four forces in a single symmetry group. Some researchers look for supersymmetry, a mirror pairing between particles and their super counterparts that could smooth the path to unification. Others consider that extra spatial dimensions might be large enough to detect in high-energy collisions, or that cosmic inflation left subtle fingerprints we might find in the polarization of ancient light. Every new telescope, every accelerator, every clever experiment adds a line to the cosmic score, nudging us closer to that single refrain. Yet the journey is as meaningful as the destination. You, in your quiet state, are part of that quest. You marvel at the night sky and feel your pulse quicken when you glimpse a distant star. You measure your own breath and sense the whisper of gravity in each inhalation. The search for unity mirrors your own longing for harmony, a unity of mind and heart, of past and future, woven into the tapestry of now. A fun fact: the force carriers for electromagnetism, photons, the weak force, W and Z bosons, and the strong force, gluons, were all discovered in experiments at particle colliders like the Large Hadron Collider. Yet gravity's messenger, the graviton, remains elusive. It's as if gravity is the shy guest at a party, slipping in through a hidden door while the other forces dance openly under the lights. Scientists still debate whether the graviton exists or if gravity arises from something more subtle, something woven into the geometry of space itself. Some believe a theory of everything will be found only when we learn to speak the language of both geometry and probability, of curves and quanta, of fields and symmetries. Perhaps it lies just beyond our reach, waiting for the next generation of minds to unravel. Perhaps the answer is a new concept we cannot yet imagine, as strange and wonderful as quantum tunneling was once to classical physicists. But tonight, you don't need to solve the riddle. Let the thought of unity between the vast and the minute lull you into stillness. Imagine a single thread connecting your heartbeat to the spin of an electron, a ribbon tying your dreams to the expansion of the cosmos. You are part of that great weave, an echo of harmony, a note in the universal hymn. And as you drift further, remember, when you awaken tomorrow, the search will continue. Every sunrise, every question asked in the quiet of your mind contributes to that grand endeavor. Until then, rest in the gentle promise that one day the universe's four voices may sing as one, and you too will find yourself perfectly in tune. You're almost there, on the cusp of the final chapter before our farewell, and yet the night still hums with one more quiet revelation. Imagine the world not as substance, but as signal, every atom, every photon, every heartbeat, a string of ones and zeros in an immense cosmic code. This is the vision of reality as information, the idea that information is more fundamental than matter or energy, the true essence beneath everything you know. In this view, the universe isn't made of particles at all, but of bits, quantum bits, or qubits that encode the state of every system. Think of it like an endless library, where each book is a record of every possible arrangement of existence, and every moment you experience is a query that pulls one page into your awareness. The laws of physics become algorithms, the evolution of the cosmos, a computation unfolding across space and time. It sounds abstract, but it's already woven into our most successful theories. In black hole thermodynamics, for instance, the surface area of a black hole's event horizon corresponds to its entropy, a measure of information. When matter falls in, information seems lost, until Stephen Hawking showed that black holes radiate and eventually evaporate, hinting that information might escape in subtle, encrypted patterns. The so-called black hole information paradox forced physicists to reckon with the idea that information must be conserved, reshaping our understanding of space, time, and quantum theory. Elsewhere, the concept of quantum teleportation relies entirely on information. Two particles become entangled, sharing information across space, so that the state of one can be transmitted to the other via classical communication, reconstituting an exact quantum state. No matter or energy travels between them in the traditional sense, only information matters. It's as if the universe whispers, "Copy," and the message appears elsewhere, leaving no trace behind. Even quantum computing, which we visited earlier, depends on treating reality as information. These devices manipulate qubits, exploring computational paths in superposition, harnessing the richness of quantum data to solve problems beyond classical reach. In a way, they remind us that if information underlies existence, then computing with information is interacting with reality at its deepest level. But what does it mean for you? It means that every thought you have, every sensation you feel, every fleeting dream is not just a pattern in your brain, but a transformation of information. Your neurons fire, transmitting bits across synapses. Your memories encode past states. Your imagination generates new ones. You are, at every moment, an information processor, shaping the universe as you observe it and being shaped in return. This perspective also offers a new way to think about the measurement problem. If reality is information, then measuring is simply updating the cosmic ledger, collapsing possibilities into recorded fact. The wave function becomes a database of probabilities. The act of observation commits one entry as true, while the rest remain archived in parallel records. The many worlds idea then looks like multiple database branches, each preserving its own copy of events. Some physicists go further, proposing a digital physics in which space and time themselves emerge from underlying information networks like a vast neural net whose nodes and connections define the shape of reality. In this picture, distances between points are defined by the complexity of information exchange. Time flows according to the updating of data structures. Particles and fields are patterns of computation sweeping through this substrate. And if that feels dizzying, let it tranquilize you instead, because information, unlike substance, is intangible and fluid. It can be duplicated, erased, encrypted, transformed without mass or volume. You could say that your presence here tonight is a tender rearrangement of data in the cosmos, a fleeting pattern that flickers into being and out again as you breathe, think, and dream. Here's something soft to hold on to. Shannon's information theory, born in the hum of telephones and early computers, set the foundation for understanding information as measurable. It taught us that information has a quantity, an entropy, and a cost to transmit. A whisper carries data. A silence carries even more. In quantum versions of this theory, the Holivo bound limits how much classical information can ride on qubits, reminding us that quantum data is richer, subtler, and decidedly strange. But whether classical or quantum, information binds the world together. It tells you the temperature of your room, the color of your blanket, the rhythm of your heart. It pulses in the code of your phone, the film on your screen, the song in your mind. And tonight, it pulses in you. Imagine now that the universe's grandest question is simply, how much information does it take to describe everything? And that the answer might be encoded on the surface of space, in the holographic patterns of gravity. The holographic principle suggests that a region of space can be fully described by information on its boundary, like a movie projected on a screen, where depth emerges from coded images. Your entire living room, your sleepy body, even your thoughts, could be the projection of data woven on cosmic shores. If so, then you are both the projection and the projector, a shimmering hologram in an abstract gallery, yet all too real in your experience. And perhaps this duality is the tender lesson. Reality is at once a story being told and a story being read, the teller and the listener entwined in an eternal conversation. As you drift towards sleep, let yourself become that conversation. Let each thought be a bit, each dream a packet of data flowing through the weave of possibility. You don't need to decode the cosmos to rest. You only need to trust that every piece of information, no matter how small, matters. And as you finally close your eyes, let the world fade into a silent archive where every moment is stored, every possibility catalogued, waiting for the next dawn to wake and query it again. For now, rest in the gentle knowledge that, at the deepest level, you are both code and coder, reader and written, a whisper in the endless library of being. You're held now in a gentle pause, the world hushed around you, every breath a quiet echo of stars. Here, finally, we return to the question that began our journey. What is real? Not the solidity of your walls or the truth of your name, but the deeper substance beneath substance, the thread that weaves maybes into was, coulds into is. Reality, as it turns out, is not a single thing, but a tapestry of possibility, observation, and connection, ever shifting under the gaze of your presence. When you look at your hand, you see skin and bone and blood, but underneath, it's fields and waves and probabilities collapsing into form. When you feel the blanket's weight, you sense warmth and texture, yet each thread is a vibration in a field that stretches to the edge of the universe. When you remember your dreams, you weave stories of color and sound, though those images flicker on the screen of your mind like ghostly photons in a darkened room. And when you close your eyes, you become the observer and the observed, the wave and the collapse, the dreamer and the dream. Realness, then, is not a fixed point, but an agreement, a mutual dance between possibility and choice. You breathe, and the world breathes with you. You think, and your thoughts sculpt the quantum haze into the contours of meaning. You love, and connections ripple outward in ways you may never measure. You sleep, and the lines between inner and outer, past and future, substance and signal, blur into a single lullaby of existence. Scientists will continue to debate how and why the wave function collapses, whether universes branch or converge, whether gravity is a gentle choreographer hidden in the quantum choir. But none of that diminishes your reality. If anything, it deepens it because it reminds you that certainty is a gift, and uncertainty a companion. That to be real is not to be static, but to participate in an ever-unfolding story, to hold questions as tenderly as answers, to rest in the space where both can coexist. So here, in this last moment before sleep gathers you, remember that reality is yours to shape by the simple act of being, that every inhale and exhale traces the outline of what is, that the line between what exists and what emerges is as soft as a sigh, and that, even when you can't see beyond the edge of your next breath, you are exactly enough, neither less nor more, to make this world true. In this final reflection, you drift beyond the atoms and quanta into the essence of reality itself, discovering that what you perceive is a living tapestry woven from possibility, observation, and connection. The solidity of matter gives way to fields and probabilities, each shaped by your breath and gaze. Your hand's warmth, the blanket's texture, and the stories you dream emerge from the same quantum fabric that unites all things. Reality, you learn, is not a fixed point but an agreement between potential and choice, a dance in which your presence collapses waves into form. Scientific debates around wave function collapse, multiple universes, and quantum gravity underscore the mystery, yet they cannot lessen your experience. Instead, they deepen your wonder, reminding you that uncertainty and certainty coexist. To be real is to participate fully in this unfolding story, to hold questions as tenderly as answers, and to rest in the harmony of both. As you surrender to sleep, let this gentle truth carry you. Every inhale shapes reality, every thought sculpts the quantum haze, and every moment of presence affirms the world's existence. In the soft space between breaths, you are both observer and observed, creator and creation.